Okay, this video is for chapter 20 on conventional energy alternatives. The case study is talking about Sweden and how it's trying to rid itself of fossil fuels. They're trying to phase out of nuclear power and switching more to a more environmentally friendly type of fuels. So that's what this case study is all about. All right, first thing you need to look at is these two charts here. These are the most important, and you have to make sure you understand the difference between energy and electricity. Okay, energy is generally includes transportation, heating, and electricity. Okay, so the number one substance used for energy is oil, then coal, natural gas, and biomass. Now, for electricity, coal is the number one. The world uses coal the most, followed by natural gas, hydroelectric, and then nuclear power. All right, so make sure you know the difference between these two topics and which are number one. Okay. And then this is U.S.'s energy consumption. So for the most part in this map, you can see that for energy generally, we use oil the most, followed by natural gas, then coal, then nuclear, and then all the other alternatives. Okay. The U.S. by far consumes the most and produces the most of nuclear power. That's what we'll be talking about. France, though, is known as the nuclear power leader, and that's just because nuclear power makes up the highest percentage of their own electricity. So if you look at this table here, you know, we have this capacity. This is how many reactors we use. However, the amount of electricity we use is 19%. Whereas France, yes, it's smaller percentages that they have for reactors and capacity, but it makes up 76%. So that's the reason why France is known as a leader in nuclear power. All right, so what is nuclear fission? This is splitting apart of atomic nuclei. So if you look at the diagram on this page, here's your nucleus of uranium-235. All right. It's split, creates energy. You get a smaller atom, free neutrons, and then you get a smaller atom left. Okay. One neutron causes a split and releases more free neutrons, which hits other atoms in a chain reaction. So nuclear fission is an example of a positive feedback loop. So make sure you know this process. Now, mined uranium is actually U-238, but we've got to enrich it to create it to uranium-235. And then what we do is it's formed into small pellets and it's made into fuel rods. And these fuel rods are stored in water. And the reason why we store them in water is because the water cools them down. So we're constantly always pumping in cool water into our nuclear power plants. And the reason why this is it helps prevent explosions. Now, the reactor core is housed in a containment building, which has like a meter thick cement and steel walls. So that's what they use as like trying a protection. All right. And this also prevents radioactive leaks from natural catastrophes like earthquakes. And if you look all here, this is your whole, in this diagram, it explains everything that we were just talking about. Okay. So one of the issues with nuclear power is what do we do with all this water that we use to cool down and keep these fuel rods from exploding? Because it's definitely contaminated, but again, what do we do with it? Because we have to constantly be pumping in cool water to cool them down. Okay. Another big topic you have to make sure that you know about when we're talking about nuclear power is half-life. It's the time it takes for half an atom to give off radiation and decay. You definitely cover this in chemistry. For uranium-235, the half-life is 700 million years. So we've been producing all of this radioactive and using uranium. However, we're stuck with the waste for a really, really long time. So this is like an issue with nuclear power is like, what do we do with all of this used uranium? Some perks of nuclear power is that it has no air pollution, nor does it emit greenhouse gases. So that's the reason why a lot of people are for nuclear power. Okay. This chart over here is pretty nifty. It gives you risks and impacts of coal versus nuclear power plants. So make sure you peruse these. These are definitely an option for an FRQ or a multiple choice question. Now, nuclear fusion. Just like this is the sun's energy. Way to remember that U and U, fusion, sun. Now, nuclear fusion, we aren't able to do on Earth yet. Scientists are trying to do it, and if we are able to successfully create nuclear fusion on Earth, all of our energy problems would be solved. We'd never have to use fossil fuels again or any other version. The problem is we don't have materials that can actually house the amount of heat that's produced with nuclear fusion because it's done on the sun. So just make sure you know the difference between fusion and fission. But ideally, our goal is to somehow be able to create nuclear fusion or replicate it on Earth. The next section we're going to talk about is nuclear accidents. The first one you should know about is 3 Mile Island. And this occurred in 1979 in Pennsylvania. And we basically had a nuclear meltdown. Fukushima, let's skip. Chernobyl happened in the 1980s, specifically in Ukraine. And if you look at your map over here, you can see where Chernobyl is. This used in the 80s, it was known as the Soviet Union, but now, after all the countries broke up, it is the Ukraine. You had an explosion and radiation spread. So as you can see here, a majority of Europe was impacted by the radiation from Chernobyl, from the fallout. And it's still an issue today. And the most recent one is Fukushima, which happened in 2011 in Japan. And this was a result of an earthquake and a tsunami, which caused nuclear explosions and a radiation exposure. Basically what happened here is the tsunami waves that we talked about came in and literally destroyed the cooling towers and then released all of that uranium out because it was and caused the explosion because the pipelines that would pump in the cool water to cool down the towers was destroyed. Big thing to remember is on an FRQ, the radiation from nuclear power plants causes thyroid cancer. Don't just say cancer, specifically say thyroid cancer. So here's a map of Fukushima and its radiation fallout. As you can see, for the most part, it went eastward over the ocean. And just a recap from earlier this year, this happened because of a convergent plate boundary with subduction. And this is what caused the displacement of water, aka the tsunami, to form. So first you had an earthquake, and then because of displacement, you had a tsunami. And the boundary happened somewhere right around here. Okay. So we keep talking about all these fuel rods with the nuclear power plant, but what do we do once they're done? So spent fuel rods, big issue is right now they're all stored at each of their own power plants. Initially, a long-term storage plan was for Yucca Mountain in Nevada in the United States. The reason why this location was picked is because it's away from large population centers. Originally, they believed it was not seismically active. However, now scientists are realizing it potentially could be. And their plan was to store them deep in underground tunnels. As of 2010, I believe, President Obama actually denied this location. Let's see. Yep. In 2010, President Obama denied this, and there really is no other option. So no one has any other ideas of where do we put all these nuclear waste? Where should we store it? So right now, they are literally just stored in underground in basements of their current homes. So this is definitely something that the United States need to figure out. This map shows you all different locations where spent fuel rods are stored and the radioactive wastes are stored. Obviously, people are not happy about it, nor are ones who want to live near it. But just to give you an update on where they are located. Okay. And just an FYI, where the thyroid is, it's in the throat area. So that's the type of children are being still to this day, 30 years later, are having thyroid cancer due to the fallout from Chernobyl. All right. The next type of energy we're going to talk about is biomass. And here's a chart of all the different types of sources and uses of bioenergy or biomass. And just remember, biomass is basically any living thing that we burn, okay? It could be wood from trees, it can be charcoal. During like the pilgrimage of like the Oregon Trail, they actually would even burn the manure of farm animals because they didn't have trees and prairies. Remember, that's why that's our farming area, because it was already cleared. It was just grassland, so they actually would burn manure. And other popular ones are corn in the United States or sugarcane in Brazil. And we actually have converted that to ethanol. So just make sure that you know corn, United States, sugarcane, Brazil, in terms of for ethanol. All right. Now, big thing is biomass is used for automobiles. It's called biofuels. Okay. Ethanol is the unpopular one that we create from corn. And we have some vehicles that are called E85, which are flex fuel. And that's because they run on 85% ethanol and 15% gasoline. These are more common in the Midwest area. We don't really have them on the East Coast or the West Coast. It's mostly in the Midwest where a majority of our corn is grown. The problems with this is that it's driven the price of corn as food up because now people are trying to use it as a source of fuel for automobiles. And it actually doesn't save much in carbon dioxide or air pollution emissions because in order to grow corn, we use a lot of fossil fuels. So it's really not the greatest alternative. And the other issue is that we don't even grow enough corn in the United States to support everyone switching to ethanol. So right now, this is the amount of area that we currently use over the country in order to grow corn. And this is the amount of area we would have to grow corn in order to support all the ethanol use to replace gasoline by U.S. drivers. And obviously that's most likely not going to happen. So it's not a most logical change. Okay, the next one we're going to talk about is biodiesel. This is pretty cool. It's made from used cooking oil. It's recycled from restaurants. It's got less emissions, it's non-toxic, and it's biodegradable. So it's pretty cool. Another source of biodiesel besides used cooking oil is algae. This was an old FRQ question. And algae is a win-win situation because not only can it be used as a biofuel, it also absorbs CO2 to combat climate change. So why wouldn't we do this more? And right now, you can actually buy a conversion kit to make your personal car run on biodiesel. So for example, in this picture here, these are students from Loyola University of Chicago. They run a van that's on that. So if you have a friend that owns a restaurant or your family owns a restaurant, you could totally run your car basically on donated, recycled, used cooking oil and run your car on that. So that's an alternative. However, it is very expensive if you have to buy the cooking oil on your own. It's actually more expensive than regular gasoline. Oh, and here's an example of like the algae that they're looking at too for the next generation of biofuels. Okay. Now, switchgrass is a potential alternative to biofuels instead of corn. It doesn't need a lot of pesticides or fertilizers, so we think it's a great alternative to corn to be used as a biofuel example. All right, we will continue with hydroelectric power in the next video.